Welcome to 3.9, Modeling Using Variation. So there are three types of variation: direct variation, inverse variation, and joint variation. The first type of variation we are going to cover is direct variation. Super exciting stuff. Direct variation occurs when y varies directly with x. So like as x is getting large, y is getting large. So that would be something like height and age, So the older you get, generally the taller you get. I mean, up to a certain point, but we're going to ignore that. So usually the older you get, the taller you get. I mean, it's not like babies are born 6 feet tall and then, they get smaller and smaller and smaller. Not the way it works. Babies are born very small, and as their age increases, their height increases. So that would be like direct variation. You can represent this relationship with the equation is right here. Y equals k x to the n. So our constant of variation will be k, which is just a rearrangement of this one. Notice that if y equals kxn, then by dividing by xn on both sides, you get k equals y over xn. So that's where they're getting that. So there's usually about 4 steps to solving these problems. They're relatively simple. A lot of variation in the real world would be you're given a data set and you have to use maybe a computer program to find maybe the variation. This is not something usually done by hand that I'm aware of, at least. So we'll start with an example. The quantity y varies directly with the square of x. So that means that its y is going to vary with x squared. So that x squared equals our xn. So it's going to vary directly. So I can start at least by saying I know it's going to vary directly with x squared, so that's something. Well, now I'm going to need to find my constant of variation. That's usually the second step. So given these two values, remember my k is now going to be y over x squared. So it's going to be 24 over 3 squared. 24 is 8 times 3. 3 squared is 3 times 3. So k is going to be 8 over 3. So that means y is going to be 8 over 3 x squared. And now they want us to find y when x is equal to 4. So we're going to have y equals 8 over 3 times 4 squared. And that is going to be 8 divided by 3 times 16. And that will give us 128 divided by 3, which is an irrational number. So we can just go ahead and leave it like this. I mean, it's a repeating decimal, so it means we're rational, I suppose, now. But I don't want a repeating decimal. We're fine there. And that's the gist of direct variation. This should be a relatively short module or section. So inverse variation, as you could have guessed it, is where they vary inversely. So this would be something like the older you get, the less you can hear. So the worse your hearing score would be. That would be an inverse variation. So that's what we're talking about for inverse variations. So they're inversely proportional. So this type of relationship is usually represented by y equals the variation of the constant of variation over xn. So notice we rearrange that and we can find our constant of variation. So let's look at this example. A quantity y varies, I spelled that weird. Gonna have to fix that. A quantity y varies inversely with the square of x. So that means that our y is now going to become k over x squared. If y equals 8 when x equals 3, they're going to want us to find what y is when x equals 4. So I'm going to use these two values, y equals 8 and x equals 3, and I'm going to say 8 equals k over, 3 times 3, that's 9. Well, now, in order to find k, I have to multiply 9 on both sides. So that's 9 times 8, that is 72. So our equation is going to be 72 over x squared. Now, when x is 4, by 4 squared, we're going to get 72 divided by 16. So we can go ahead and break this down, and we will get 8 times 9 over 4 times 4, 4 times 2 times 9, because 4 times 2 is 8, over 4 times 4. So we can get rid of this. We can also break this bottom 4 down further into 2 times 2, and these will cancel. So we will get 9 divided by 2. And that is our y. Not too bad. Another one is joint variation. So a lot of situations in real life are not just as simple as two things affecting each other. It's usually a multitude of things affecting each other. So joint variation can either be direct or inverse. But it will include multiple things other than just two things. So if it varies directly, we're looking at this equation. If x varies directly with y, we're going to be looking at this equation. So x varies directly with the square of y and inversely with z. So it's going to look like this one, because it's going to vary directly with the y and inversely with z. So we know it's the square of y, so we're going to have ky squared divided by z. That's a z. So now if x equals 40, y equals 4, and z equals 2, we have to find k. So we're going to have 40 equals k times 4 times 4, and I'm just going to break that down into factors to get rid of this one on the bottom. So that is going to become 40 equals 8k. So we're going to divide everything by 8. Going to give us k equals 5. So now I know I'm going to have x equals 5, y squared divided by z. So now when I have y equals 10 and z equals 25, that's going to give me 5 times 100 divided by 25. And 100 divided by 25, as everyone knows, is 4. It's like quarters in a dollar. So 5 times 4 is going to equal 20. So our x is going to equal 20. And this essentially is it for modeling using variations. These questions are relatively simple. You will probably have to think about some if you really start stacking up the joint variations. But for the most part, this is it. We do have some things we'll go over, but it shouldn't deviate too much from this. So thank you, and I will see you next time.